Chapter 8, Objects and Classes, Part 3. So when we're talking about instance variables of an object, we think about it that each object of the class has a separate set of instance variables. So let's assume that we have a class for a clock. Each instance of the clock would have its own instance variables, its own copy of the time. So Los Angeles, New York, and London could all display a separate time. The object variable is contained in a reference, such as looking at this example, register 1 contains the address of where the cash register object is stored in memory. Notice that register 1 has its own copy of item count and total price, and register 2 has a separate item count and total price. Each object variable has its own instance variables. We cannot access instance variables directly from objects. We need to go through the public interface of the class. So if we try to access item count from the main method, we can't do it because it's private inside the cash register class. Instead, we'd need to use getCount, the public interface of the class. This prevents outside entities from corrupting the data stored in a class, and this enables an object-oriented concept known as data hiding, which means that you have to use the public interface methods to access the private data. So to implement instance methods, we're going to use the private instance variables, but we make the methods public. So public void add item double price, item count plus plus, total price equals total price plus price. So notice that we are directly referencing the instance fields, but this add item method is going inside the cash register class. So it will be part of the same class in which item count and total price are defined. So let's take a look at the syntax of instance methods. Instance methods start with the access modifier, then the return type, and then the method name, just the same way that static methods do that we've written before. Notice they are declared inside the class of which they are part. So the public cash register class contains public void add item double price. The instance variables can reference the instance fields directly. Implicit and explicit parameters. So we have used explicit parameters so far. Notice that in this example, if we want to call the add item method, we put something in parentheses. That's an explicit parameter. And that explicit parameter is passed to the method. But there's something else that's passed to the method, and that's the implicit parameter. The implicit parameter is a reference to the current object. And the reason for this is, while instance fields or data are stored separately in each object, the instance methods are shared in memory. And so Java needs to be able to determine whose object owns that method call. So the implicit parameter, its name is this, by the way, THIS. The implicit parameter is passed whenever we are calling an instance method. So it knows whose instance fields to act upon. Constructors. A constructor is a special method that is run whenever an object of the class is created. There are three things you need to know about a constructor. Number one, it's public. Number two, it has no return type, not even void. And number three, it has the same name as the class. So look at this example. Public cash register has the same name as the class, it's public, and it has no return type. And what we're doing inside the constructor is initializing the instance fields. That's pretty much all the constructors do, is they set up the object to be used. They initialize the object. We can have multiple constructors. This is called an overloaded constructor. So constructors will of course have the same name. All constructors will be public, no return type, same name as the class. But how can we distinguish one from the other? The same with overloaded methods that we looked at previously. An overloaded constructor will vary from a different one by its parameter list. So in this example, bank account with no parameters, that's called the default constructor, and then we have one parameter which takes an initial balance. This is an example of an overloaded constructor. They differ by their parameter lists. Here's an example of syntax of constructors. public, no return type, same name as the class, and then an optional parameter list. Know that if we don't provide any constructors at all, Java provides a default constructor for us. A default constructor initializes numeric instance variables to 0 and reference types to null, and default constructors do not take any arguments, no parameters. However, if we write our own constructor that accepts a parameter, that means that we no longer have access to the default constructor. So if we want to have one, we would have to write it ourselves, as done in this example. A constructor creates an object by initializing all instance variables defined in the class. If you don't initialize an instance variable explicitly, Java does it for you by default. Numbers are set to 0. Boolean variables are initialized to false. Object and array references are set to null, N-U-L-L, null. That pretty much means there's no object here. It is good programming practice to initialize all instance variables in the class. So to do it yourself by writing a constructor. Null object references. So if we take a look at this example, string local name, we haven't provided any value for a local name. So when we try to access name.length, there's nothing there. It's null. And so we can't access any methods. And that would give us a null pointer exception, which basically means there's no object for this reference. By default, numeric variables are initialized to null. So if we try to access name.length or local name.length, either one of those cannot be accessed, cannot be run.